Good. Welcome everyone. In the last class we have discussed about what is polynomial, and in this today's class we shall discover more about it. Okay. At first we shall recap our previous class, then we shall move forward. Okay. So this is our polynomial general expression, that is a0 plus a1x plus a2x square and so on up to an x to the power n and so on. This is our general expression where ai are real numbers for I 1 to n, and okay, and n is positive integer. And we have discussed in the last class that what is degree of a polynomial. So let's check some examples, like determine degree of the following polynomial. Okay, 4x minus 5x square plus 6x cube whole by 2x. So at first we shall express it, that is it will be 4x by 2x, and we have already discussed this sum also. And if you have not watched the previous lecture, at first go for it, so it will help you to make easily understand. So in this algebraic expression, the highest positive integer degree is 2. This, so degree of this polynomial, whole polynomial, is there 2. Okay. So next, 3x minus 2 and 2x cube plus 3x square. So at first we break it. So we use here the distribution property. So This is our distribution property. And then simply multiply it. 6x to the power 4 plus 9x cube minus 4x cube minus 6x square. And the highest degree is here 4. This is. So degree is 4. Okay. So our next question is an example of a monomial of degree 5. Monomial of degree 5. So we already know that monomial means only one term. So we should choose one term of degree 5 of x. So that may be x to the power 5 also an example. Of course it is. Or we can easily join a scalar with it, like minus 5 x to the power 5 also true, root over 7 by 2 x to the power 5 also true, and etc. We can make many examples. This monomial. Next is binomial of degree 8. Binomial of degree 8. Binomial means only two terms, and degree 8 means the highest power of x must be 8. So it may be a constant with plus and x to the power 8 also true. We can add here a coefficient like this. It may be x to the power 8 minus 7 x to the power 6 also true. We should remember that any power of x should not cross the 8. Otherwise, the degree will not be 8. Okay. So another example is minus 9 x square plus root over 7 by 2 x to the power 8 also. Okay, so in these examples there are two terms that is satisfied also, and highest power of x, that is 8. So these all are binomial of degree 8. Okay. Next is trinomial of degree 4. Okay, it may be degree 12. Okay, so it may be three terms here, like x minus x square plus 3x to the power 12. It is true, yes. We can take a constant term like 7 by root over 5 minus root over 3 of x to the power 10 also we can take, because we should remember the power of x should not cross 12. And here we can take x to the power 12. We may choose a coefficient here also. I am taking 9 as I wish. So we can make many examples. Next is A monomial means only one term of degree 0. That means if a polynomial has degree 0, then the polynomial should be a constant polynomial. So we just take as a constant value for a monomial of degree 0, that is a 9, it may be root over 3, it may be 7 minus root 5, that is a constant value. Yes, of course. Remember, it is not double term because there is nothing x. Both are constant term. So both are togetherly will be a0 here. Remember. So it may be 7 by 2 also and etc. Okay. Now I am taking a exercise for you. Make a binomial of degree uh, maybe 7. So it is your exercise to do. Okay. So I shall be right back after some time. Your exercise to do. Okay. So I shall be right back after some time. Your exercise. So now the answer, it will be like 2x. I'm taking as my choice. Root over 7 by 12. Also I'm going to x to the power 7. Yeah. So this is a example of my own choice. Now we shall discuss how to put value of a polynomial. Okay. So the actual definition is, if f of x be a polynomial, then f of x at x equals to t is obtained, then the value of f of x at x equals t is obtained by putting x equals to t in f of x, and it is denoted as f of t. So that means if this is our general expression, like f of x equals to a0 plus a1x plus a2x square a3x to the power 3 and so on, and if we are like to determine what is f of alpha, then just put substitute x by alpha in it, like this. Okay, we are just substituting x by alpha. Yeah. So let's check some examples, like if this is a polynomial x cube minus 5x plus root over 7 x square minus 19. So what will be p of 1? That means we just substitute x by with a value 1, like this: 1 cube minus 5 into 1 plus root over 7 into 1 square minus 19. Just I am putting the value. Okay, so it will be minus 23 plus. So what is minus p of minus 2? So we shall now just substitute the x by minus 2. So that will be minus 2 to the power 3 minus 5 into minus 2 plus root over 7 into minus 2 the square minus 19. If that is minus 8 minus minus, and it becomes plus 5 into 2 and minus a square, that will be positive. So root over 7 into 2 square minus 9. Here it is. Okay. That's 2 minus 17 plus 4. So now my next topic is, that is very important, and that is zero of a polynomial. So that is the definition. Let p of x be a polynomial if p of alpha equals to 0, then we say that alpha is a 0 of the polynomial p of x if p of alpha equals 0. So if I have a polynomial f of x as x minus 2, then f of 2 will be 2 minus 2, that will be 0. So 2 is a 0 of f of x, right? Another example I am taking. Uh, P of x is 3x plus 2. So now we have to find the value of 0 of this polynomial. So if alpha be 0 of q of x, then q of alpha will be 0. So we just put the value here. Q of alpha means 3 alpha plus 2 will be 0. And then we get the actual value of alpha, that will be minus 2 by 3. So minus 2 by 3 is the 0 of the given polynomial q of x. Got it? Next is find 0 of this polynomial, and the polynomial is p of x equals ax plus b. Okay. So let k be the polynomial. No, sorry, my mistake. K be the 0 of the polynomial p of x. Then p of k will be 0. And now we just put the value here. P of k means we just substitute x by k of this polynomial. So that will be a into k plus b equals to 0. Now we have to find just the value of k, that will be minus b by a. So minus b by a is the 0 of the polynomial p of x. Okay. Now my next topic is what is the 0 of a constant polynomial. Listen, constant polynomial means there is no term of x. That will be like 9, or it may be some root over 7 by 5 and anything. And the degree of x is always be 0. So there is no 0 of constant polynomial. So my conclusion is that is a constant polynomial does not have any 0. Because you cannot find the value such that a constant value will be 0 if it is non-constant. Okay, like you cannot find the value of such x such that the 3 will be 0. It cannot be possible. Okay, You cannot find the 0 of minus 2. It cannot be possible. So a constant polynomial cannot have any 0. Okay. Next point is a linear polynomial has one and only one 0. That means a polynomial of degree 1 must have only one 0. Hmm. It cannot across the number of zeros than 1. So a linear polynomial always have only one 0. It cannot have two different zeros. Okay. Okay. So you can get that 0 cannot be always 0 of a polynomial. My explanation is, if I polynomial I am taking like this, x plus x square here. So what will be the 0 of this polynomial? That will be p of 0, because only the value 0 makes the polynomial 0. Yeah. Any other value other than 0 cannot give us the 0 value. So here 0 is the, so here 0 is the 0 of this polynomial. But on the other hand, if I have a polynomial like this, x minus 2, so here we can find that only two value is the 0 of the polynomial f of x, but 2 is not a 0. So it is not necessary to be 0 always be the 0 of polynomial. My next point is a polynomial can have can have a repeated 0. R-E-P-E-A-T, repeated 0. As an example, if I take a polynomial like this, that is x square minus 2x plus 1, and this is a very familiar example, that will be, it is x minus 2 x minus 1 the whole square power 2, and that is x minus 1 and x minus 1. So our two zeros are 1 and 1. So here 1 is the repeated 0 of this polynomial. Okay. So now my question is, verify that 1 and 2 are zeros of this polynomial, that is p of x equals to x squared minus 3x plus 2. So how can I verify? So I just put the value here. At first I am putting the value 1. P of 1 means 1 square minus 3 into 1 plus 2, and that will be 1 minus 3 plus 2, and that is 0. So yes, 1 is a 0 of this polynomial. Next I am putting the value 2 here. So that is p of 2, and that means 2 square minus 3 into 2 plus 2, and that is 4 minus 6 equals to 0. So 2 is also a 0 of p of x. Next point is a question. If 2 and 0 are zeros of the polynomial f of x equals to 2x cubed minus 5x squared plus ax plus b, then find a and b. So at first it is given that 2 and 0 are zeros of this. So if I replace x as 2, so we will get what? That will be 0, as 2 is a, here I am writing, as 2 is a 0 of f of x. That means I am putting the value 2 into 2 cube minus 5 into 2 square plus a into 2 plus b, and that will be 0. So we have 16 minus 20 plus 2a plus b. So that implies 2a plus b equals 4, and I am named this expression as 1. And again we have that 0 is a 0 of this polynomial, so f of 0 must be 0, as 0 is a 0 of f of x polynomial. So I'm just putting the value 2 into 0 minus 5 into 0 square plus a into 0 plus c, and that implies b equals to 0, because every terms will be cancelled out here. So here I am getting that b equals to 0, and from 1 and 2 we have that 2a plus 0 equals to 4, implies 2a equals to 4, and a will be 2. So a is 2 and b is 0. So our original polynomial is 2x cubed minus 5x squared plus 2x plus equals to 0. So this is our original polynomial. Okay. So this is all about for today. I am ending here, and in the next class we shall discuss about the division algorithm and remainder theorem of polynomial. So thanking you for joining.